Hi, so let's begin with the practicals. The practical that I'm going to deal with today is Helmholtz resonator experiment. Okay, and the aim of this experiment is to study the relation between the frequency and the volume. Okay, the relation between the frequency and the frequency of the tuning fork that will be given to you, and the volume of air that you will be there in the Helmholtz resonator. So the relation between them, in case of a narrow neck resonator, the resonator given to you is a Helmholtz resonator, and determine the neck correction factor K and unknown frequency of the given tuning fork. Okay, so unknown frequency also you will be finding out from this experiment. Fine. So apparatus used for these experiments are, of course, the resonator. Beakers will be given to you to pour water into the resonator, or if you get extra water into the measuring cylinder, then to pour it into that beaker. Of course, you will have measuring cylinder to measure the volume of water that comes out from the resonator. And of course, you will be also given tuning forks of different frequency, known and one unknown frequency tuning fork will also be given to you. So in addition to these apparatus, I also needed, since it's COVID, I also needed laptops, cameras and microphones. Okay, so of course you won't get it. Then formula to be used is n square into v plus k v naught equal to constant. So of course we'll be only using this part of the formula for the graph, because we are going to plot graph. In case you don't plot graphs, then you use this equation, but since we are plotting graph, we'll be using only k v naught. We'll show you at the end of the experiment how it is. Then n is the frequency of the tuning fork here in this formula. V is the volume of the resonating air. So volume of the resonating air is nothing but the volume of water that we will be getting. V naught is the neck volume. I'll get back to it. And K is the neck correction factor that we'll be calculating. So what is a Helmholtz resonator? It's a glass funnel like this. Okay, with there's a knob here for you to open and close the flow of water. To control the flow of water, there will be a glass knob for this glass Helmholtz resonator. Also, you'll be given a beaker. Fine. And something about neck correction that I was talking about. So it is this volume of water within this portion of the neck. Okay, so you'll be initially when you'll feel the water, you'll feel the water up to the brim, up to here, and then you will remove the water up to the neck, and that volume will be called the neck volume. Okay, neck volume of the air. So that will be used for correction factors. And of course you will be given a what do you say, let me just zoom it for you here. This is the neck volume. Okay, so water from here to here is removed out before you start the experiment, and that particular volume of water that will be taken out will be called the neck volume of the water. Next, of course, you also have the measuring cylinder, okay, from which can measure water from 0 100 I'm to say 10 ml up to 100 ml. Okay, and as you know, ml is equal to 1 cubic centimeter. So whatever volume of water that we will be getting will be written in terms of cubic centimeter. Fine. So that's about these two apparatus. Apart from that, you will be given tuning forks. I have taken 4. You may be given even 5, one additional one also. Okay, of different frequency. You can see this is 512. This is 426, 288, and this will be the unknown one that you will be using. It will be covered. Rest, if you look here, you will find these values that I have written down. Since it is very old tuning forks and rusted, you cannot see them clearly. So I have written it down here. So these are the tuning forks. Also observe that the length of the tuning fork increases with the decrease in the frequency, okay, of resonance of that tuning fork. So obviously the unknown tuning frequency that we have to find will have to be less than 288 for sure. Look at it, its length is a little bit more than that of these tuning forks that is given to you. Fine. Also, you will be given this small rubber pad kind of thing on which you will be hitting the tuning fork to create the vibrations, so that you can keep it on the neck of the Helmholtz resonator, so that there could be resonances observed. So this is about this. So this is the complete setup, which you don't have to do. This will be set up for you already by our lab attendants. Okay, so you don't have to worry about it. It will be done for you. So this, but you can look at the setup how it is, since you are not in the laboratory right now. So you can look at the setup of the experiment. Okay, there's a water filled up to the brim here, and of course this photo is clicked after in between of the experiment. Okay, otherwise there will be water up to the brim, and then of course there's a small measuring cylinder down to collect the water. So how to hold them? So this rubber pad can be held on your left hand. If you're a right-handed person like me, you will prefer to hold the tuning fork on the right hand. If you're a left-handed person, then of course shift it. You can get that rubber pad on your right hand. So hold it that way so that you have this rubber pad for you ready to be hit by the tuning fork. Look at the way I'm holding the tuning fork. I'm holding the tuning fork at the end of it. Okay, I'm holding it very tightly. Okay, and at the same time I'm holding it right at the edge of it so that I don't put any force here. So do not hold the tuning fork at this point. So hold it here. Okay, there is a small kind of a shape given to you. Also hold it behind that. Okay, and when you're hitting on the rubber pad, see that you hit it holding that end on this. Okay, so remember that you don't have to, you should not in fact hit the tuning fork very hard onto this rubber pad, otherwise you may end up breaking the tuning fork. All right, so just hold it tightly, but hit the rubber pad with very less force, means not too much of force. Okay, enough force that it can create a vibration in the tuning fork. Fine. All right, so these are the basic things that I had to tell you before we go into the laboratory. So since we are now ready with all the basics and you have seen how each of the things looks like closely, so I think now we can go to the physics laboratory to perform this experiment. So I will see you after the experiment is over to discuss the graphs and the results. So see you after the experiment. Hi, so welcome to the laboratory, and we are now going to perform the Helmholtz experiment practically, and you're going to watch it. The theory part of it has already been discussed, and what you're going to do over here is only we are going to begin with the practicals. Okay, as you can see the setup here, we have the Helmholtz tube here, oscillator tube, which is filled with water, and there is a measuring cylinder. Okay, and we are given the different set of tuning forks here. Okay, this is a 512 hertz tuning fork. Then we have of 426 hertz. Then we also have of 288, and one of it will be given to you as unknown. Okay, now unknown is the frequencies that we are to find. That is the aim of this experiment. Fine. Okay, we'll be also given this tire, rubber tire, to just hit your tuning fork on this so that you can create the required oscillations to be used for the measurement. Fine. So before we begin, what we need to do is we need to fill this tube fully up to the neck, and also ensure that while doing that there is no air bubble in it. So we have now filled this up right up to the neck, and what we are going to do is measure the neck volume, which will be used for the neck correction later. So we are given this measuring cylinder. Fine. Okay, so ensure that there is no air bubble inside this. Okay, and if you find any, you can just take a small wire, push it in, and try to get rid of those bubbles. Okay, so if you are done, if you are ensured that there is no air bubble inside, then we can just turn this knob and take off the water till it comes up to the neck of the tube. So the moment it comes to the neck of the tube, you can stop it, and you can, using the cylindrical measuring cylinder, you can measure how much of water has come out. So in this first reading that I've got here, it is 14 ml, and just note down the 14 ml. Okay, so we need to repeat it at least 2 more times. We need to take this reading of neck correction at least thrice so that we get the mean value. So what I'll do is, instead of taking off the tube and again putting on the water on top, what we can do is just put the water again up to the neck. So remember the first reading that we had got, it was 14. So now we just open it again till the water comes down up to the neck. And after that, again measure this. It has come to now 28. So the last reading that we got, minus 28, should give you the new volume. Fine. Again, we'll take it one more time, thrice. And again, open the knob so that the water comes down up to the neck. And this time the reading that I've got is 40. So we'll be just subtracting the previous reading from these readings, and then we get this neck correction volume readings that we get, and we just note it down in our reading and just find the mean of it. Okay. After that, we can start taking the readings for oscillations. Okay, and what we could do is, since we are given different tuning forks of 512, then we are also given of 426, then we are also given of 288, and so on. Okay, so different tuning forks have been given. So what we could do is, or it is advisable to do, is that you use the tuning fork of the highest frequency to start with. So by doing that, what will happen is that you don't have to fill the water again and again, because highest frequency tuning fork will give you the lowest length of vibration, okay, of the vibrations in this helmholtz frequency oscillator resonator. Fine. So if you use 512, then whatever volume you will get when you use the next tuning fork, that is of 426, okay, you will not have to refill this helmholtz resonator. You will have to just open the tap and continue taking your readings. Okay, so to avoid refilling the helmholtz resonator repeatedly, what we could do is simply take or start with the highest frequency tuning fork. Okay, so I'm doing that. I'm taking the 512 frequency tuning fork, and how to hold the tuning fork and how to use it has already been discussed before starting the practicals. Please listen to that carefully. Okay, so I'm just holding it, and this is the tuning fork which I'm just you can see how I'm using it. I'm just hitting it very slowly, not that hard, and also I'm holding it at the tip. Okay, so this is to be taken care. Otherwise, if you hit it hard and if you're holding it somewhere else, if you're hitting hard, then very likely the tuning fork will break. Okay, so please take care of that. And as we are doing it, okay, the water that should come out, okay, should be very slow. All right, the water that would come out should be very slow. All right, so you remember the last volume that we had got. Fine. Okay, so we can just take that off, and we can now continue taking our readings for each of the tuning forks. So 512, you'll be getting, when the frequency of this will match the length of resonance, the sound that will come should be the highest, should be very maximum, and then you can confirm that that is the also length of resonance. Fine. All right, so what we can do is we can just keep this on very slowly. Okay, let the water keep coming out. All right, and every time you can place the tuning fork on top to check. As of now, there is no sound here. Fine. Okay, I just put my microphone right in front of the this, so that you can hear the sound that is coming out. All right. Okay, so I put my microphone here, so you'll be now able to see, or you'll be able to hear the sound. Okay, so still there is no sound. All right. Okay, or even if it is, it's a very little one or very small one, very light one, okay, that you're getting from the fork itself. We need to get the sound from the helmholtz resonator. So still it has not started. Okay, so we continue this. You can see the rate at which the drops of water is falling is very slow. Okay, all right, so still it has not, I can see here that it has reached to almost 55 ml, but still there is no sound. Now a very faint sound has come, but I do not know whether your microphone can detect it. I continue. The intensity of sound is increasing. It's still increasing a bit. I just keep continuing. There's some sound that I can hear now. All right, so since I've started hearing some sound, I need to slow down the flow of water. I need to get much louder sound now. Pour out some more water and check. So I need to get still louder sound, or I can just check whether I can get some louder sound, louder than what I heard now. Okay. So take out some little water. More. You can hear the sound that's coming now from the fork. Right. So we can just try and see if we can get some more louder sound. So I take off a little more water. Okay. So this is quite a good sound that I've got, and it is at around 93 ml. I can still try, take out one more drop of water. So this sound that I've got is a bit more louder than what I had got previously at around 92 ml. This is 94 ml. Still, I can take out one or two more drops of water and check if I can get some more louder sound. If it does work, then possibly we can take that particular reading. Yes, so this sound is still bigger. So what I'll do is I'll just take out another 2 drops of water. Yes, so I've got a very loud sound by now, okay, and it is 96 ml as per this measuring cylinder. Fine. So I think I can note down this reading for 96 ml. What you could do is now you need to take this reading one more time. So for that reason, you can just take off this cylinder. Note down your reading first at 96 ml, and then again take off the cylinder, put little bit water back into the resonator, little bit. So I have now reached to 82 in the measuring cylinder. I know approximately the reading is at 96. So what I do is now I can confidently go down up to 90, 92, and at 92, 93 again slow down and take reading slowly and see where the second reading is coming to 96 or 95. You go by your ears, okay, you go by how loudly you hear the sound. So I need to take out some more water. So it's on 94 now. Still take out another 2 drops of water. Find the intensity of sound is almost same, and yes, this time I've also got it at 96. So I can take the second reading also at 96. Okay, and the 2 readings that I've got for the tuning fork of frequency 512 is 96. So I just note it down, and of course the mean value of the frequency also comes out to be mean value of the volume of water that I got is also 96 ml. Fine. Okay, so similarly I continue this for the lower frequency, that is 426. As I already told you, that since you have already used a higher frequency for measuring the volume of water, this length will now increase with decrease in the frequency. So even though I'm taking 426, I need not replace the water back into the helmholtz resonator. What I can do is I can continue taking the water out, okay, confidently, and get the readings. Fine. Also be very careful. Now we have almost reached 100 ml, so you can take out 100 ml of water from here. Fine. So we have got 100 ml out. So you remember 100 ml of water is already out. We just pour it out here in the beaker and make the measuring cylinder empty. Remember it was 100 ml. And now slowly we begin again taking the water or allowing the water to move out, and at the same time trying to find out the frequency of vibration. Fine. Okay, so we just continue slowly. Okay, so there is some sound is coming, so make it very slow now. Just slow it down, just stop it, and now start again. Try one more time. This is loud. Maybe another 2 drops. Just note it down. It is around 36 ml. You just take out some 2 drops. So the intensity of sound decreased with this water that I took out. It was okay. So what I do is it was 36. So just put the water back a little bit and slowly try to increase. Slowly try now again to take the proper reading. So I brought it below 30 ml. 100 ml is already poured out in the beaker. Okay, so I just pour out maybe in drop wise now, little. This is 32 ml. Loud. So I think I can confirm 32 ml. Maybe I can just go for a few more and just check. So what I'll do is take off a little more water. So down 34. Intensity of sound has still increased further. Very loud, 34. Going very slowly. Not much, still on 34. So now on 35. So intensity of the sound decreased with the 1 more ml that I put. So I can confirm 34. So this reading is going to be 100 plus 34 ml that I've got now. So it's 134 ml of volume of water. Fine. So what we can do is take this water back again and take another reading, second reading. As we already know, it's around 34. So we need to go very slowly at around 34. So we can take out some water. So I've already done 32. It's quite loud. And just take off 1 more drop. Enough. 33. So this time when I took off that 1 more drop from 32 to 33 to 34, I found there was a decrease in the sound. Okay, so we can take the second reading for this one as 33. That is 133. 100 plus 33 as 133. Fine. Okay, so this is about the tuning fork of 426. Similarly, we need to do for 288. Okay, so since there is still a lot of volume of water that I can put in here, I'll just keep this on slowly so that the drop of water keeps coming out. And I use this tuning fork of 288 hertz. No sound at all. There's no sound at all. So continuously the water has been flowing down in this measuring cylinder. At the same time we are doing this, trying to find out the length of vibration. I'm not hearing any reasonable sound. At the same time, I need to slow down here because I can see it is approaching 100 ml. So it has reached 100 ml. So in total, 200 ml of water, of volume of water is already out from this helmholtz resonator. So I empty the measuring cylinder, and now I will begin again. Okay, in this measuring cylinder, remember already 200 ml of water is already out in the beaker, and so whatever we are going to measure is now going to be that reading plus 200, not 100. Okay, so I just continue allowing the little bit of water to come out every time. There's no sound still. Okay, some slight sound I've started getting here. I do not know whether the microphone can record this sound for you. There's no still a good reasonable sound that I'm getting, but maybe the frequency of the tuning fork may be too low. All right, so we will go on till we hear the maximum moment. If I stop getting what sound I'm getting now, then I will stop and take the readings again. So starting getting little louder sound. Maybe the sound is decreasing or it's increasing. Got slightly louder sound than what I was getting. Yeah, now the sound is increasing. Yes, it's still going louder. Yes. I need to be very careful at this point because we are reaching almost 100 ml. It's already 95 ml out. Take off a little more water. Still louder. Still increasing. Still increasing further. So I'll just take off some more drops of water. I need to be very careful. I'm almost on 98 ml here. I'll just take out one more drop, maybe 99. Okay, I find that the sound has decreased a little bit than what it was. So I think the reading, the answer is somewhere between 95 to 100. So I just take off the water a little bit back, put it back into the resonator. It's come to 90 and I go very slowly from here. Very slowly I'll go from this point. So it's at around 89. So I reached 90. Take off little by little now Let me just be on a very careful side. For some reason I missed out the louder sound. Let me repeat it again. Let's take off some more water, put it back and go very slowly from where, very slowly from this point. It's around 87. Take off little water. Quite good. This sounds quite good to me. Yeah, I would like to finalize on 94. Okay, so 94 plus 200, that is 294 for this particular tuning fork. Okay, so if I want, I can repeat it one more time for the frequency of 288. All right, so 294 is the reading. Next, what we have is a unknown frequency. Okay, unknown frequency, you can see the tuning fork that is given is much longer than that which I used just now, the previous one, that is 288. So undoubtedly the frequency of this will be lower than the one which is given here. So unknown should be lower. So I will use this and I will continue to take the water out to check whether I get the unknown sound. It's completely damp. Let me take out 100 ml of water. Absolutely no sound. All right, so I'm going to pour this out. If the given beaker also gets full, then remember there is another beaker given to you, which you can throw or drop some water into the new beaker that is given to you, and empty your measuring cylinder completely. And place the measuring cylinder down. You can start. Allow the water to pour out slowly. I've started getting very slight sound from the unknown frequency, but it's too low, too damp. Yeah, it's increasing. Still increasing. It's increasing. Increasing. It's increasing. Alright, that started decreasing, so I'll stop here and pour some water back. So I know now the reading is somewhere around 10 to 15 ml in between what I got. So I just pour some water back. Okay, and now I need to go very slowly for the unknown one. Remember, this is an unknown reading that we are taking, so be very careful, be very sharp at taking this reading, because it will be used in your plotting of your graph. All right, so I go very slowly here, drop by drop, very slowly, and try to hear. started decreasing, so I just put some water back again. I'll try to go very, very slowly now from here on. I think the loudest. Yeah, so this is the loudest one. So I'll just stop here, and this will be 75. Okay, so what we got over here is 75. 300 ml of water is already been poured out into the beaker. So 300 plus 75 is 375 is the reading that we need to note down for the unknown one. So we need to take this reading one more time. So 375 was the reading. So I just drop the water little by little now. In fact, very slowly. It's quite loud. So around 73 that I got, just maybe one more drop. Yeah, still loud. 74. Little bit. We are still on 74. Yeah. So the second reading that I would take is 374. So 74 plus 300 is 374. So that's it about this experiment. So we are now need to go back onto our we need to go back to our table on plotting the graph and finding the unknown frequency using the graph, okay, from the table. So see you at the while plotting this in the next section. Fine. So welcome back. Sorry about the poor frame rate that was used while recording the experiment, but I will see that there's something done about these frame rates. Okay, so the video was getting stuck every time, but I hope the experiment was very clear to you and quite easy about how it is to be done. Correct. So these are the readings that we got. So volume of the neck, there were three readings that we took. First volume that we got was 14 ml. Afterwards we continued, we added more water to up to the brim of the neck. Again we got 14 ml. And third reading, something happened because of which we got 12 ml. Okay, I'm just taking those readings which we have got from the experiment. Always remember, be careful about these things. Okay, maybe you could have even taken the fourth reading, okay, and seen that it came around 14 ml. Fine, but no problem. All right, so just add them all and divide by 3 to get the mean. So volume of the neck, the mean volume of the neck is 13.33 cubic centimeter, because ml 1 ml is equal to 1 cubic centimeter. Fine. So here are the observation tables. We have the volume of the neck, which is calculated with 13.33. For frequency of 512, we had got volume as 96 and 96. Obviously mean of that would be 96. We need to square it. We get something like this, and of course the inverse of the square of the frequency is 3.81 into 10 raised to minus 6. Okay. Similarly, using the similar way, we can do it for 426. We get this value. Okay. We can also use it for 288. We get this value, and of course the value that is important to us is the mean value of the volume. Fine. Of course there is no such parameters for unknown frequency because we do not know the frequency, and that is what we have to find out. So once we are done with this, we need to plot a graph as shown here. You will have to plot a graph of volume on the y-axis to the 1 by n square on the x-axis. All right, and I've plotted it using one of the software, so it does not look like a graph paper to you, but you will have to plot it on a graph paper. You need to write your x-axis, you need to write your y-axis. Okay, plot the graph papers. I have 3 points. Now what do we know? Like, how do we find the unknown frequency? We only know the volume of water that we got, okay, while using the unknown frequency, and we got it something like 370. If I go back, 374.5. all right, so 374.5 has been plotted here, and you just extrapolate it. Just draw a very straight line till it touches this straight line graph, and from this point you need to draw a straight line down here. All right, so what will happen? The intersection point will give you 1 upon n square. That's here. 1 upon n square is nothing but it is found out to be 1.53 into 10 raised to 5. Find the inverse of that, you will get n square. Find the square root of that, you get the frequency. All right. So if you go back, if you remember, the tuning fork that we used for unknown was much longer than all others. So obviously it had to be less than 288, and you see we got 255.65 hertz. So that shows that very much we must be correct. Okay, of course I do not know the unknown value, but definitely it has come correct. For the K factor that we have to calculate, how do we do it? We just take this graph, we extrapolate a straight line down. All right, and this extrapolated line, wherever it meets here, that value we take is equal to kV naught, where V naught is the neck volume that we have found, and therefore K upon V naught is a value. Okay, of course I forgot to place it down here. It comes around 4 point. All right, if I just calculate it, give me some time, let me just calculate. It will come to around what's the calculator? Okay, so it's 57.77 divided by 13.33, 4.33. okay, 4.33. So now I had actually calculated it, that's why I remember it was something around 4. This value is little bit on a higher side, it should be little lower. Okay, it should be roughly around 1.5 of that order, but for some reason it has gone a little higher. Okay, but nothing to worry. So these are the very simple calculations of this experiment, and now finally the results. Okay, the neck correction factor K is found to be 4.33, and the value of the unknown frequency is 2.5565 hertz. Okay, so that is about this experiment, a very interesting experiment in which you can find out the unknown frequencies. Okay, a very beautiful experiment given by Helmholtz to us using the resonator. Okay, how the volume of air can help us to get the unknown frequency of the tuning fork. Okay, so very interesting, very interesting experiment. Fine, so I hope you have liked it. So if any questions, we can discuss at the end of the experiment now, after the end of the session now. And so done. So thank you.